before I start, I'd like to say that as EPOCA coordinator, I'm very happy with this training course, and I'd like to congratulate the OCB team for putting it together and make it so successful. It was oversubscribed, and it's very pleasing to see so many people in this room, and I'm sure it will make a big difference. So a short introduction to C-carb. First of all, why a new kind of package? The reason is that in 2003, the situation was frustrating for people like me, not using a PC and not using also Microsoft products. So I don't have Excel. We had no way, and also for Unix and Linux users, there was no program to use. CO2, a program was called CO2 and was designed by Michel Franquignoul. It ran on DOS, CO2-6, we heard about it, on Windows or on Excel. And there is MATLAB also, that routines put together by Richard Zibby and Dieter Wolf-Gladrow. And all need commercial software or emulators to run. And some of us believe that there was a need for a cross-platform package that would run on any kind of OS, Windows, Unix, Linux, and Mac OS 10, and Mac OS 9 at the time also. So C-carb is an R package. R is a language and environment for primarily to do statistical computing and graphics, which is similar to S, which is a commercial software. And I think R was named R, just for the fun of it, for this company doing the S program. So it's both a language and an environment. And there are so many packages in R, packages to do statistics, linear modeling, nonlinear modeling, and time series analysis, you name it. I mean, it's quite impressive, the amount of packages available on R. It's highly extensible. That means that you can make an R and C-carb function if you like. And we will discuss this a little later. R is very good also to do publication quality plots. Really, you can fiddle with your plots and have them, really nice looking, with a lot of time and energy spent, however. R is available, as I said, as free software. So it means that the code is available to anybody, and anybody can alter this code, change it, provide new functions, etc., as long as you follow the GNU general public. And as I said, the main advantage is that it runs on all computer platforms that I know of. The downsides, there is one really. The learning curve can be seen as relatively steep. R is a command line program, similar to MATLAB, if you like. So there is no menu, no fancy checkboxes, things like that. You have to type or copy and paste your commands into a console. So for code that is needed to do this figure here on the left-hand side, first of all, you use C-carb to calculate the data. That's the Revel factor as a function of PCO2. So the first line, the carb function here calculates the Revel factor. The second line plots this thing. The third one puts the grid on it. And the last one puts the line. So to do a relatively simple graph, I mean, you do need to type in or to copy and paste a significant amount of commands. And obviously, and also, as you can guess, R is not forgiving. You just forget one comma or one bracket, and it won't work, of course. So that's the downside. It's open source, so C-carb is also open source. You can access the code. It's updated regularly, and recently we have added new functions. James Orr provided new functions, Caroline Sotart also, and Héloïse Lavigne. And new functions can be added at any time. For example, at this meeting, I would like to add the solubility product for magnesium calcite together with Andreas Andersson hopefully we will manage to include this into the package this week, and perhaps the new buffer factors that Chris has described early on. So what is C-carb for? There are 33 functions in C-carb, and you will certainly not use all of them. There is one major one that I will describe later. You can use it to calculate parameters of the carbonate chemistry, to go from 2 to 6, from 2 parameters to the 6 parameters of the system, because I am dropping here Andrew H2O, water. You can use C-carb to calculate buffer factors, dissociation constants, calibrate the potentiometric pH and seawater density. And also there are functions to assist ocean acidification perturbation experiments that I will describe later this week. So now let's move on to R. So I am launching R now. I will get all. That's commands. I didn't expect it to be so big on the screen, so let's see how it works. And here I am opening with R a file which is called C-carb training. That's a file that I will send you at lunchtime, so you can reuse the code and experiment with the code yourself, because 45 minutes is a very short time for you to do hands-on exercises. So I have put all the commands that I will use in a text file that you can use later this week. So I am opening this file, and that's the C-carb training file. So we have 2 windows. On the left, the file containing all the commands, and to the right, the console, all the commands will be typed. So R is a calculator. For example, I can, of course, calculate very simple kinds of calculations. And what I want to point out, there is a very nice function in R, is if you use the upwards arrow on the keyboard, it repeats the previous, the bottom, it repeats, the previous commands that you have typed. That's the commands I have typed, before. So it's very convenient. You can recycle the commands. You don't have to type them all over again. So that's a nice feature to use. You can also create vectors of commands. For example, I can, using C, that's combine. I am combining here 5 numbers. So I'm combining those 5 numbers into one vector. It's called a vector. That's quite useful when you want to input several parameters into a C-carb function. You can do the same thing using this command here, 1 to 5, 1 column 5, and that will also produce this vector of digits from 1 to 5. And there is a third way to do that, which I am mentioning here because it is extremely useful, is to do a sequence. So if I type sequence, I want to go from 1 to 5 by increments of 1. By increments of 1. And that's, I have my vector of 1 to 5. So those commands are repeated here in this text file that I will send to you. When you have such a text file on the left, you can select part of it, and if you do command return, this command is being sent to the console. So I have selected here this line, which creates the vector 1 to 5, and I do, or I'm not sure on a PC keyboard what it will be. Mac, it's command, it's perhaps Alt, or do you have a command key? Alt, okay, one of those two, and you do return, and you see my command has been sent to the console. If I want to copy those 3 lines, which are highlighted in blue on the left-hand side, I do command return, all those three are sent to the console. So that's a nice way to use previously typed commands. Boom. Something else you can do with R is to assign, of course, vectors or numbers to variables. And you have one example here. Test 1 is I will put those 5 digits into a variable called test1. So I select it here. I do command return. And this is sent to the console here. So I have put here the 5 digits into the variable test. And if I want to check what variable test has in it, I just type test1 and I got my 1 to 5. I continue with the basics of R before getting into C#. You can do also computation with vectors. For example, this vector that I have just created, or this variable test1, I can multiply it by 10. If I do test1 multiplied by 10, each of those numbers will be multiplied by 10. And if I create a new variable, so test2 contains 1 to 5. And if I can also do the difference between two variables. That's quite convenient. If I do test1 minus test2, obviously I have 0. So the two vectors have been added or subtracted. These are just the basics with R. I'm not, there are many more, of course, features to it. Now, how can you get help? There are several ways to get help. One is to type help C, for example. That's the combine function of R, the one we use to combine those 5 digits together. I type help C in parentheses, and then a new window opens, and you have here a detailed documentation of this function. Usually it starts with the usage, an example of how you use it, the arguments needed, details, values, references, and most importantly, for beginners, examples. That's very attractive to have examples. And every function of R has a documentation or help manual, if you like, to it. You can use also, instead of help C, you can use, there is a shortcut, that's question mark. C does exactly the same thing. Also calls the documentation for C, combine. There are other functions which are useful for beginners, and one is the function example. It provides you, if I type example and a function, for example, log, it will here provide a few examples that I can use to understand what the function, how the function logs work. And you see, after I typed example log, I was returned with those various examples which are provided here. So that's also for beginners, it's a very nice thing to understand how a command works. And you can use also demo. For example, if you want to see what R can do in terms of graphics, if I select this line here, I do command return in order to send this command to the console here. Here we are. So I type return, and a new window opens, which is a quartz window. That's a window for graphics. And if I hit return, as I am asked to do here at the bottom, return again. Here are examples of graphics that you can do with R. And more importantly, the code used to to produce this graphic is available in the console window. So you can really understand how this graphic was done, and you can copy and paste, recycle, whatever. Return again. Here you go through several kinds of graphics together with the code on the right-hand side used to do those graphics. that's a great way to understand. So I'm closing this graphics window. And I jump on in C#. So I assumed you have downloaded R and also something else before. There is another way to get help. That's if you type a function name here on the top of the of this window here. If I type log, for example, and return, you see that at the bottom a new window, some kind of a drawer opens, and you have also the help, which is here at the bottom, on the help on the functions. So that's quite convenient because you have your commands here that you are typing, and you can see the help file here right at the bottom. You don't have to go to a different window. It's all there. So the first thing before using C# is obviously to download R and to install C#, and instructions were given to you through the OCB website. And there is a critical step that you don't want to forget, is this one. You want to load the C# package. If you don't do that, you cannot use C#. So I'm loading C# here by typing or command return on library C#. The command has been sent here to the console window. I am skipping a few of those things. You can go through the text if you like later. But C# has, well, I will do it. So if I type help on package C#, so that's what shown. Some information on the package, the package name, what it does, the version, and when it was produced, the authors, who is the maintainer, what's the URL to have access to it. But what you are very much interested in, I think, are the functions. And the functions are here listed. It's kind of an index of functions. For example, K1, that's the first dissociation constant of carbonic acid. And then you have all of them listed. All the 33 functions are listed here. A nice way to if you know a function is there and you don't remember which one it is or what the syntax is, you have access to it there. So there is a function called buffer to calculate the buffer factors described by Frankie Newell in 1994. And this function here, the documentation is there. So it starts by telling you what it does. So the buffer function returns buffer parameters of the seawater carbonate system. It provides, that's a very important piece of information, the syntax for the function. You see that the buffer function starts with a flag which can be 1 to 25, but there is a jump between 15 and 21 here. The flag is basically the input parameters. Flag 1 means that you know pH and CO2. Flag 25, you know PCO2 and DIC. So the flag here is just indicating which kind of input parameters you have. Then the next two, variable 1 and variable 2, are those parameters. For example, for flag 1, the first variable here will be pH, and the second variable will be CO2. In that order, it's important that you don't put them back to front. The next parameters is salinity. Salinity is here 35, temperature, hydrostatic pressure, the phosphate concentration, the silicate concentration, the formulation for K1 and K2. By default, it's the Lucker formulation. The way to calculate the dissociation constant of fluorides, here is Perez and Fraga, and there is another way to do it, and here is the pH scale. T stands for the total scale. That's the default. Here you see that when you have a parameter given, for example, S equal 35, it means that you don't need to include this parameter if you want to use this default value. If I am happy with S35, T25, etc., I can stop my function with this. Buffer can be only those three numbers, a flag, the first variable, the second variable. All the others are optional if those default values are suitable to you. And then you have a list of all the arguments. Flag, as I have already described what it is. Variable 1, variable 2. It's important for the units. Everywhere it's mole per kilograms, mole and not micromole. That's a common mistake, except for PCO2 in microatmosphere. The second variable, it's the same. It's always mole per kilogram. Salinity, temperature in degrees Celsius. P, the hydrostatic pressure in bar and not decibar, which is different convention as compared to CO2 PT, the total concentration of phosphate in mole per kilogram, silicate in mole per kilogram, K1 and K2. So by default, it's L for Lücker et al. There is another option, it's R for using K1 and K2 from Roy et al. CCARB presently doesn't have all the other possibilities that Chris showed in CO2 cis. Obviously, that's something you could add. It's very simple to add. KF, by default, it's the dissociation constant from Perez and Fraga, and there is also, it can use DG for using the Dixon and Riley 79 formulation. And then the last thing is the pH scale. T for total scale, F for the free scale, SWS for the seawater scale. CCARB doesn't use NBS or NIST scale. Then you have additional information in the documentation that sometimes it's useful. Value, that's what is returned by the function. This function returns all those values, the various buffer factors described by Franquignoul et al. Then the authors of the section, the references used, and then the examples. Very, very useful for beginners again. You really see what is happening. And you can just copy and paste also. If I just want to try this example here where I use flag 8. Flag 8 is pH and total alkalinity. So I want to know the buffer factors for, if I know pH 8.2 and total alkalinity 2,340 micromoles per kilograms, salinity, etc. And I am on the total scale. I just need to copy this. Sorry, go to the console and paste this function. And then CCARB returns the various buffer factors that Franquignoul described. Okay, so I'm going to skip this, perhaps show you the Bjerrum plot that was described by Andrew Dixon earlier. There is a function to do those plots, and you have several examples available. So if you want to produce such a plot, that's the code here that you need to use. Well, I'm not going into the detail, but with just 5 lines of codes, you can reproduce this, and you can also customize it to different purposes. For example, for the phosphate speciation, you can also do colors and overlay different plots in order to show, for example, here the effect of salinity, of temperature, sorry, on the distribution of CO2 bicarbonate and carbonate at 2 different temperatures, 0 and 25 degrees, salinity, pressure. Anyway, there is a function to do this kind of graphics in CCARB. Now we are going to look at the most important, I think, function, the one that you really want to use and which is similar to CO2 cis, that's CARB. So carb is the function that you use to calculate parameters of the seawater carbonate system. That's how it looks like, very similar to buffer. First of all, a flag indicating which kind of parameters you have, the value of those two parameters, variable 1, variable 2, and then exactly similar to buffer, the function buffer, salinity, temperature, total pressure, total phosphate, silicate, how you want K1 and K2 be calculated, which scale you want to use. So similar to, that's the documentation, similar to buffer. It's everything is laid out here, some details. We have, obviously we are happy to get feedback. Someone, what's his name? Andreas Hoffmann indicated to us a bug in one of the functions that we have. So we got the pressure corrections wrong, a small difference, but it was significant. So we have added, for example, in the manual, a detailed explanation on how the pressure corrections are made, and provide also information on the source of bibliographic, the papers that we used. Values returned by carb, that's obviously salinity, temperature, pressure, and then these are the values returned: pH, CO2, PCO2, FCO2, bicarbonate, carbonate, DIC, total alkalinity, omega aragonite, and omega calcite. The references and examples. So let's explore carb. And for example, we could use the first example that Chris provided in his presentation. So what I'm going to do, he was using DIC and total alkalinity, so I am copying this piece of code, which I paste here, and I just update the numbers using Chris's. So he said total alkalinity was 2231.8, 2231.8 micromoles. Remember, carb works with units moles per kilogram, so it's important to put 10 to the minus 6 here. DIC, Chris used 2013. Salinity was 33. 33,366. Temperature was 20. Pressure was 0. Phosphate was 0.1.8. But this in units of mole per kilogram. And the pH scale was total scale, was it? Okay. And you used Dixon because you wanted to be nice with him. Dixon and, what is it, Dixon and? Was it Dixon and Riley or? It was, but you called it DG throughout. Oh, why is that? I don't know. Anyway, so I hit return, and that's what carb returns. The flag was 15 because we knew total alkalinity and DIC, the salinity, temperature, pressure, pH on the total scale. That's calculated by C-carb, 7.997. The CO2 concentration, that's here in values mole per kilogram, PCO2, FCO2, bicarbonate, carbonate, DIC, remember also moles per kilogram, total alkalinity, omega aragonite, and omega calcite. We have done together with Andrew and Chris comparisons of CO2 and C-carb. The few examples we have used, we got the same numbers to the fifth decimal place, was it, or sixth?
No, because they're different constants. If you use the same constants, yes.
Yes, that's
but
what.
it's almost impossible to use the same constants between the two systems.
Ah,
Because
yeah,
the
yeah,
Luca
right.
constants
Is not
and
in.
the Dixon and Malero 87 constants ought to be the same, but they're not. And I could never. I think my computer didn't work in 1987 because the code that I had in 1987 and the printouts were clearly correct, and K2 was slightly different
Okay.
in the two fits.
Okay. So I guess the option will be to add more ways to calculate K1 and K2 in C-carb, and likewise perhaps in CO2-cis, and make sure that we get the same kind of thing. So in the text file that I sent, you have other examples. For example, here, when you have total alkalinity and DIC, and you want to use a different pH scale or a different formulation for K1 and K2, that's relatively simple. You have also the case flag 8, where you know pH, and that must be total alkalinity. These are variations of the carb function, depending on the parameter. Flag 24, that's an interesting one because it's very useful, and it was not originally included in C-carb, and that was contributed by James Orr. When you look at the flags, all the last ones here, when 2 is known and one of the other parameters, those functions were added by James. I think it's very important for the community to use PCO2 as one of the input variables. Something that is useful also in C-carb is that you can use several values in a single. For example, if you know total alkalinity and you want to know PCO2 at various pHs, you can use the function sec, the sequence values of pH between 7.9 and 8.2 with increments of 0.05 pH units. So if I do command return, or perhaps less, of pH between 7.9 and 8.2. And then in turn, I can use this, this variable using flag 8. So I remind you that flag 8, and I remind myself also that flag 8 is pH and total alkalinity. So I am using here the variable pH, which contains those 1, 2, 3, 4, 5, 6, 7 values, and total alkalinity, which I know. It's 2400 micromoles per kilogram. And if I hit return, now, and I do it again, now C-carb has not only one line in the output, but it has with all the values of pH from 7.9 to 8.2. So you get all the carbonate chemistry between those two pH values with increments of 5. So that's quite convenient to use the sequence function in order to build a larger output, if you will. This I will skip. How much time do I have left, Sarah? 5 minutes, okay. Two more, I think, items that are useful. Here you have the carb function using flag 8, the same as before, using the variable pH with those 7 pH values in it. And if I run this, you notice here that I have assigned this output to a variable called carb. It could be anything else. It could be TMP for temporary. Never mind. So now the variable TMP here contains the output of our function, the carbonate 7.9 at 2. I want to show you is that you can extract only part of this big table. If you're not interested with all those numbers, if you want to have only one column, you can just type TMP, that's the name of the variable, dollar. And if you're interested with PCO2 only, PCO2. And then you get only those 7 values of PCO2 that you can reuse to do a plot or a calculation or whatever. You don't have to deal always with this big and for example, I can use this way to extract, for example, here I can extract pH and PCO2, and I do a simple plot of how PCO2 varies here from 300 to 600 as a function of pH on the total scale from 7.9 and 8.2. Obviously, at the salinity, temperature, etc., that was included in the carb function. So you can extract data from the output and put them into another use, for example, for a plot. Obviously, the plots you can customize. I don't want to spend time on this now. Yes?
It's okay to name a variable the same name as a function?
Yes, it knows how to do it. It's like magic, but you can do that. Yes. But you may want to avoid it because it can be confusing to do that. But yes, R knows to, I mean, there is no conflict between variable names and function names. So I have shown you how to do those calculations for 7 pH values between 7.9 and 8.2. But say if you want also to include a second variable, total alkalinity, you want to see how it affects the calculations between 2 values, 2200 and 2600. So here we are manipulating, if you like, at the same time pH and alkalinity. So what I do here, I use the sequence function. And instead of saying I want to go from, instead of specifying an increment, I'm just saying that I want only 10 data out. So it will, C-carb, if I do that, we will have 10 values between 7.9 and 8.2. I do likewise for total alkalinity between 2200 and 2600. And then there is here a function. I don't have too much time to explain it, but it makes a grid out of those 10 and 10 values. It makes a big expand grid. Couple of variables between, the first one is pH, the second one is total alkalinity. I have 100 of them for the 10 values of each. And then I can use carb with this. Here, C-carb has returned, the function carb returns 100 lines of, this is line number 1. It starts with pH at 7.9 and total alkalinity, we don't see it, it's at the bottom, 2200. And then you get your, you know, for the whole range of pH and total alkalinity there. And how, what is it that I am drawing here? PCO2 changes as a function here on the y-axis. Of course, you can customize. You will be able to do that, to look at this in the file. And to close, 2 more items. The first one is there is a function to convert pH. If you have pH on the free scale, for example, and you want to convert it into the total scale, there is a function to do that. It's called pH-conv. I don't have the time to do it, but you can look at the documentation or you can ask me how it works. So you need to tell which, from which pH scale you want to go to another one, which direction, what is the pH value, salinity, temperature, and pressure. Okay. And finally, there is a way to read files that's very convenient because some of us have a large amount of data. So you can have these I'm just checking one of them. Which one is it? That's a file that Andrew Dixon, Chris Saban, and I, you know, the exercise. Oops, that's not what I want to do. We compared values using CO2 and C-carb, and that's the small text file that I have built. The first line here is the name of the column, the header, the flag, PCO2, total alkalinity, salinity, temperature, pressure, PO4, silicate, K1, K2, Kf, and scale. These are the required parameters for the carb function, and I have used examples provided by Andrew, although I have made a mistake because I have used the Lücker formulation at 10 degrees, which is incorrect, but I will do better next time. So if we go back to R, you can read, there is a function, I am running out of time, but there is a function to read this. Where is it? Here. That's where we read. There is a function read table, and I just provide the name, the file name. I'm just telling this function that there is a header, the header equal true. What is the separator for the file? It's a comma, and the classes of the column. I can provide more detail later. But the read table is very useful because you can read this table and run here carb using parameters read from this file. And similarly, you can save data to a file using the command write.table, and you can save it on your disk for archiving or future use. So that's it. It was not hands-on, but I had a lot of things to cover. You know, the basics of R, the basics of C-carb. Hopefully, you will be able to train during the week. And also, there is Kim Yates is going to give a hands-on exercise on using CO2 Perhaps we can run on some of the examples, you know, on C-carb as well. And I will be in the room. And if you have questions, I will be happy to answer. Thank you. Yes?
I just want to say that since I also am an R dummy, I found that there's a PDF online that's a short reference card to R. It's like one-page
That's
PDF,
true.
and it gives you a summary of all the really basic commands. It's really useful to like make things like vectors and import tables, and it's sort of like, you know, shortcuts to get all the basic commands for R.
Thank you for mentioning that. There are lots of resources available on the CRAN website. That's where you went to download R. If you explore this website, it's just incredible the amount of information there is on packages, manuals, books. There is even a forum. When I started with R, I had many questions, and you know, you just send a question to the forum, and 10 minutes later you get six replies. It is very, very active. And people are really helpful in this community.
If you can alert me to that PDF, I'll post it on the website so that people can get access to that. And I think, Jean-Pierre, are you going to send out this
At lunchtime, yes, this text file to everyone, and also the small input file that I showed, so that you can try all the exercise, all the examples on your computer this week. Yes.
Is there a way to spawn R and C-carb from a separate program to call it? So if you could remotely, I mean, I use IDL for most of my image processing, and I usually dump that down into some sort of batch file. And the one thing CO2 Sys
I'm sorry, I don't know the answer to that. I'm not quite an expert with R. I'm just like, no, I don't know. Thank you.